Okay, the directions are to verify the identity. Cosine 3x minus cosine x equals 4 cosine cubed x minus 4 cosine x. So I'm going to write down the side I start with, which is cosine, it's going to be the left side, cosine 3x minus cosine x. And I'm going to work one step to the right, and then I'll work downwards. You can just keep working downwards if you want, but make sure you write down the side you're starting with. So the trick, I gave you a hint in this one. The trick was to rewrite the 3x as x plus 2x. And you need to add in the parentheses if you do that. And then we still have the minus cosine of x on the end. And so when I use this trick, I have in mind that I want to use the sum formula for cosine. So the sum formula for cosine says that the cosine of alpha plus beta, remember the template is cosine times cosine, and when it's plus here for the sum formula for cosine, we actually have a minus in between the products. So cosine cosine minus a sine function times a sine function. And it goes alpha, beta as far as the angle goes, and then we just keep the same order in this identity. So cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. This is not part of the proof. I'm just writing down the identity to kind of show you what I have in mind here. Okay, so splitting cosine x plus 2x up using this identity, just realize that x is acting like alpha and 2x is acting like beta. So just applying this identity, I get the cosine of x times the cosine of 2x, and then don't forget the minus, and then sine x sine 2x. Okay, now remember what I'm trying to do. I'm trying to turn this into the right-hand side of the original identity. So one thing I can do is write everything in terms of cosine if possible. And also, I see a cosine of 2x here. I can rewrite that using the double angle formula for cosine. Well, one of the double angle formulas for cosine. The one I'm thinking of here is the cosine of 2x. Since I want to write everything in terms of x, actually in class I presented it as the cosine of 2 theta. So again, these are just identities I want to use in my proof, in my verification of this identity. It's not part of the proof. So I think I want to use the one with just cosine. So cosine 2 theta, remember, equals 2 cosine squared theta minus 1 is one of our identities for the cosine of 2 theta. So I'm going to make that substitution right here. And okay, if I do that, I get cosine x, and then times, let's put it in parentheses, 2 cosine squared. Okay, it's going to be, well, okay, what's acting like the 2 theta right here? Oh, it's just 2x, isn't it? So it's a direct replacement. Just replace x, where theta with x rather. So we get 2 cosine squared x minus 1 in parentheses in place of this guy. So that's the substitution I'm making. I'm also going to use the double angle formula for sine. So the sine, that guy, the sine of 2x, remember, turned out to be 2 sine x cosine x. And that's just the double angle formula for sine. Okay, so what can I do now? Well, one thing I can do algebraically is I can distribute this cosine of x here and here, and that gives me 2 cosine cubed x minus just cosine x distributing over the minus 1. minus 1 times cosine of x is just minus cosine x. And then here, if you look at what we have here, we have a sine x and another sine x. We can change the order of multiplication, and it becomes 2 sine x times itself, which is minus 2 sine squared x, and then we still have this cosine of x on the end. Okay, now remember, I'm looking at the right side. I want to turn this whole thing into the right side. So I need everything in terms of powers of cosine. So I'm doing good right here, right here, right here. I need to write that in terms of cosine squared actually. And I'm going to use the identity that says sine squared is equal to 1 minus cosine squared right there. So I'm going to replace this guy right here with 1 minus cosine squared x. And then all of this will stay the same, cosine cubed x minus cosine x. And then we still have the minus 2 and the cosine x outside these parentheses. This 2, minus 2, and cosine x. Now next, I'm going to go ahead and distribute this 2, but also this cosine. So it's like distributing minus 2 cosine x. So it goes there as well. So just think of it as distributing minus 2 cosine x to both the 1 and the minus cosine squared. And what do we get? We get 2 cosine cubed, just copying down what's right here, and then x, and then minus cosine x, and then minus 2 cosine x plus 2 cosine squared x, because I'm distributing a minus over a minus, so plus 2 cosine, not squared x, but cubed x. Cubed, 2 cosine cubed, or cubed, doesn't matter, x. And then I see like terms. So look, this guy and this guy, they are like terms. So you have 2 cosine cubed x plus 2 cosine cubed x. That's going to be equal to 4 cosine cubed x. And then there's a problem right here. I can see it already. I'm supposed to get minus 4 cosine x, but I have minus 1 cosine x here, minus 2 cosine x here, which only makes minus 3 cosine x. But here's the beauty of identities. I know I made a mistake. I know I should get 4, so let me go find my mistake. So I search. Oh, look, I have this minus cosine x here, but I don't have it here. And so I just dropped it, and that will happen. It even happens to professors. But the trick is just finding the mistake. And so, now I have 1 minus, in this second to last step, minus cosine x, minus 2 cosine x, minus cosine x. That is minus 4 cosine x, which is exactly what we're trying to get. And so we fixed it. It works. It's done.